Alright guys, welcome to vodcast 8.2. Here's where we're going to jump into the real heart of stoichiometry. We talked about the simple stuff last time. Remember that the key point was the mole ratio. And so we're just going to jump right in here. This is what I like to call the roadmap for doing stoichiometric problems. And it works out this way. So what we learned how to do yesterday, or in the previous vodcast in 8.1, is that we had moles of one thing, the given, and we turned it into moles of an unknown using something called the mole ratio, okay, where I had 1 mole of N2 equals 3 moles of H2 or something like that. And that's what I did. So that was what we call a step 2 to 3 problem. Today what we're going to do is we're going to introduce grams into it. Now, here's the deal. The heart of it is still the mole ratio. That is still the central part of any of these equations. And you guys should have a worksheet that has this on it and sort of walks you through it. The only difference when you have grams given is that you're going to have to use the molar mass to turn your grams of whatever it is, your given or your unknown, into moles, because everything in stoichiometry revolves around moles. So if I have grams, I use molar mass first, turn it into moles. If I need grams, if my unknown is in grams, I do the mole ratio stuff, and then at the end I do the molar mass. Okay? So I'm going to walk through a bunch of these. Hopefully these will look okay once you see them. Remember, you always got to have the mole ratio. All right, so let's get rolling. So first off, what mass of water could be produced from 5.2 moles of propane? Okay, so we're going to start off the same way we did yesterday. Given, you'll notice that these numbers probably even look pretty familiar from the previous lesson from vodcast 8.1. So that's my given. The difference here is that my unknown now is not in moles of water like it was yesterday or the previous lesson, but it's in grams of water. Okay, that's going to make a little bit of a difference. So we still need a mole ratio. I still need a relationship. My relationship between propane and water is 1 to 4. Okay, so 1 mole of propane, C3H8, is equal to 4 moles of water. And in our previous lesson, that would have been it. That would have been all I needed to go from moles to moles. But I'm not going from moles to moles. I'm going from moles to grams. So if I look back at my sheet, moles to moles is the first part. But the second part then is going to be to get grams of unknown, I have to go through the molar mass of the unknown. So anything you have grams over here, you have to find the molar mass for. So we know how to do molar mass. I'm going to go ahead and work this one out just to sort of refresh your memory. So I've got 2 hydrogens. Hydrogen, if we look it up on the table, has a mass of 1, so that gives me a 2.0. Okay, I've got 1 oxygen. Oxygen is 16, and that's going to give us another 16. Okay, and so we're going to plug that in, and that's going to give us 18 grams per mole, or more appropriately to what we need, we can rewrite that as 18 grams of water. Okay, again, important to label what it is, equals 1 mole of water. Now, what that does for us now is that I can go from moles of propane to moles of water, and then moles of water to grams. So just like when we did our conversion factor problems at the beginning of the year, now I've got all the steps that I need. So in this case, I need 2 conversion factors, right? So I'll put my given in there. In fact, let me shift some of this stuff off so that we're not too terribly confused here. I'm going to move that down a little bit. I'm going to move this over. Okay, so I've got 5.2 moles, that's a 5 by the way, of propane. And again, you have to label these things. If you don't label them, you're going to mess them up. I promise at some point you're going to mess up bad. So if that's moles of propane, then remember that whatever's in the given box is what I want to cancel first. So 1 mole of propane. Now, where did I get that 1 mole from? That's from right here. And so on the top of that goes the other half of the equality, which is 4 moles of water. Okay. Now, I don't want to end up in moles of water, though. So, like, if I just stop right here and canceled what's here, moles of propane cancel. And what I'd be left with then is moles of water. I don't want moles of water, though. I want grams of water. So that's where the molar mass comes in. So 1 mole of H2O That's from right here. And then on the top is the 18 grams of H2O. Okay, now calculation-wise, cancels out moles of water. The only thing I'm left with then is grams of water right here. And so my final answer I know is going to be in grams of water, which is good. That's where I want it to be. And so then it's just a matter of plug that into the calculator. We plug that into the calculator. You're going to get something like 374.4. I've only got 2 sig figs here, though, so my answer should only have 2 sig figs. So I'm going to round that to become 370 grams of water. Okay, so only difference, still mole ratio. Okay, that is our mole ratio that we used in our previous lesson. And this is the molar mass. Okay, so let's work out another couple of these. So how many moles of propane, or how many moles of carbon dioxide would be produced by burning 54.7 grams of propane? So what's different in this problem then is that I have grams at the beginning instead of at the end. So in the last problem, my unknown was in grams, and in this problem, my given is in grams. Okay, so I'm looking for moles of CO2. So if we look back at our roadmap, in the last problem I went from 2 to 4, and this problem I'm going to go from 1 to 3 because I have grams of given and I want moles of the unknown. Okay, so this is what we call a 1 to 3 problem. All right, now I always need a mole ratio. It doesn't really matter what else is going on in the problem. I always need the mole ratio. So 1 mole of propane is 3 moles of CO2. Okay, so we've got to get all of this stuff written down. Again, I know that you're thinking you can work it in your head, but trust me, just trust me, work it out. Okay, so we got to find the molar mass of propane. You calculate all that out, and again, I'll do one more. After this, I don't think I'm going to do all the molar masses for you because you should know how to do them at this point. So 3 carbons times 12, that's from the periodic table, 36. 8 hydrogens, hydrogen is 1. Okay, so 8 times 1 is 8. Add all that up and we get 44. And what does that mean? It means 44 grams of propane, okay, equals 1 mole of propane. Okay? Now, do I have enough stuff? Pretty much do. Let me move this out of the way real quick, guys. All right, do I have everything I need? Well, I can go from grams of propane to moles of propane. I can go from moles of propane to moles of CO2. So I got everything I need. Now it's just a matter of plugging it in. I know I'm going to, if I've got 2 equalities, then that means I need 2 conversion factors, okay? So start with your given, 54.7 grams of propane. Now it's going to be different in this problem. As every other problem we worked, our first thing here was moles. Not so in this case, because if I start with grams, I got to get rid of grams first. So 44.0 grams of propane. That's 1 mole of propane. Okay, and then once that's done, now I need my mole ratio. So 1 mole of propane, 3 moles of CO2. Cancel out the stuff that cancels. Moles of propane, grams of propane. Going to be left with moles of CO2. That's good. That's what the problem asked for. We punch all that in our calculator, and I'm going to get 3.73 moles of CO2. All right, let's work some more. So in this case, I've got a 2-part problem. If I burn 32.7 grams of propane, how many grams of oxygen are consumed or used? And then how many grams of water are produced? So same given for both problems. Okay, and the only thing that's going to change here then is going to be the unknown. So I've got grams of propane. Okay, in fact, I'm just going to use that again. I'm going to clone that. Check that out. We're just going to bring that down here. That's going to be my given for both problems. All right. Hopefully I didn't cause anybody's mind to explode when I did that there, but that's what that is. Okay, so my unknown for the first problem is grams of oxygen. So now, this is what I would traditionally call a full stoichiometry problem. Why is it a full stoichiometry problem? Because if I look at my roadmap, I'm starting at grams of given and I'm ending at grams of unknown. So there's basically 3 steps that I need to take. Molar mass of the given, mole ratio that we always take, and then molar mass of the unknown. All right? So let's walk through that. Whoops. Okay? So I know I need the mole ratio. That should always be the first thing you find. So 1 mole of propane is 5 moles of oxygen. Okay? So 1 mole equals 5 moles. Okay? And then I need to find the molar masses of both things. So I already found the molar mass of propane in the last problem. It was 44. If you didn't, work that out the same way you normally would. I'm not going to work it again. In fact, I'm not working any more molar masses here because we're going to keep chugging on. And then molar mass of oxygen, well, so 1 mole of oxygen. Okay, it's O2. Oxygen is 16. I've got 2 of them. So that's going to make it 32 grams of oxygen. Okay? And now we're going to set up our conversions and work it out. In this case, I have 3 conversions. So I need a little bit more room. That's okay. Start with your given, 32.7 grams of propane. We're going to get rid of that first. I'm going to use this one first. So I want to get rid of the grams. Okay, that's 44.0 grams of C3H8. 1 mole of C3H8. Sorry, I crammed it in there a little too much, guys. So that gets rid of grams of propane. So now I got moles of propane, need to get rid of that. So I'm going to use the mole ratio. And sort of the big trick here is that if you're doing a 3-step one, which means you start at grams and you end at grams, the mole ratio should always be the middle conversion factor. Okay, and that's exactly where it is here. So 5 moles of O2. And then I want to get rid of moles of O2 and get grams. Okay? So we're going to plug all that in. Let me cancel what cancels. I already canceled the first part. Moles of propane cancel. Moles of oxygen cancel. Going to end up with grams of O2. All right? We're going to punch that in the calculator, and we're going to get 119 grams after we round to sig figs. You actually get like 118.9. We're going to plug it in that way. Okay? Now, how would I set up the next one? I would do exactly the same, okay, except that I'm going to have a different mole ratio. I'm still going to use the molar mass of propane, and then instead of the molar mass of oxygen, I need the molar mass of water. Okay? So you guys can go ahead and work that one out. Pause the video. Give it a try to work it out, and I'll give you a big hint here. The answer, once you're done with it, is 53.5 grams of water. Okay? All right. So you can check that one in class tomorrow if you didn't figure it out. So let's work like the hardest of all types. Now, what makes this one so hard? Well, first off, there's no equation. So that means we have to write the equation. So we're going to read through the problem, write the equation, and then we're starting at kilograms, which is going to add another step in. So we'll see how this works. So first off, write the equation. Ammonia can be produced. If it's produced, it means it's on the right-hand side. You're like, how do I know that ammonia is NH3? We just took a test on that stuff. You should know it. Okay? From the combination of nitrogen and hydrogen gases. So nitrogen and hydrogen. Okay, why are they H2 and N2? They're diatomic. They're always that way. Okay? And we want to balance these real quick. So I'm going to put a 2 in front of this and a 3 in front of that. That'll give me 2 nitrogens on each side, 6 hydrogens on each side. So we're balanced. And then we got to set up the problem. So given 1,250 kilograms of N2. My unknown is moles of NH3. Okay, so we're going to do the mole ratio. 1 mole of N2 equals 2 moles of NH3. Okay, so we got that. I need the molar mass of anything that's in mass. So 1 mole of N2 is equal to 28 grams of N2. Again, how do I know that? Okay, nitrogen's 14 times 2 is 28. And then kilograms to grams we also need. So there are 1,000 grams in 1 kilogram. Okay? So, plug it in. The only thing really different here is that we started with kilograms, but that's okay. 1,250 kilograms. Got 1 kilogram on the bottom and 1,000 grams on the top. Technically, those are of N2, so I'm going to plug those in that way. Okay? And then we use the molar mass of N2, 28 grams of N2. And then we've got 1 mole of N2 up top. And then we use our mole ratio. Now, again, the kind of weird thing here is that the mole ratio is the last thing we use here. But that's okay. Everything is still going to work out good old normal way. Okay? Cancel what cancels. Moles of N2, grams of N2, kilograms of N2, left with moles of NH3, which is what we want. Okay? And once you plug that into your calculator and do sig figs, it's going to be 89,300 moles. All right? So go back and watch those again if you need to. I know that was some hard stuff, so make sure that you got all that. Walk through all those problems individually. If you have questions, make sure you ask them in class. Thanks, guys.